This is the result obtained from scope 1. You can see here, this is the input sine wave generated from the sine block. And then this is the sample pulse generated from the pulse generator. Okay, we have set the pulse here is the amplitude 1, and also the period here is 1 second for every pulse. Okay. This is the result that we get from scope 2. You can see here, the first one is input sine wave. Okay, the signal that we get from the sine wave block. Second one is the sample pulse. Okay, this one we get from the pulse generator. And then the third one is the quantized signal. Okay, so this is the result that we get after the quantization process. Okay, so what you have to do is that you have to take the value for each of the pulse here. So overall total for the pulse here is 10 pulse. So for each of the pulse here, you have to get the value for the input sine wave and also for the quantized signal. Okay, what you're going to use here is that by using cursor measurement, you can obtain the value for the input sine wave and also quantized signal. So it's better for you to use the horizontal cursor instead of the vertical one, because you want to read the value here and also the value for the quantized signal. Okay, so we have two cursors here, 1 and 2. Okay, I decide to use the first cursor is to read the sine wave, and the second one here is to read the quantized signal. Okay, now we go to the first pulse here. Okay, so this is the first pulse. So you have to read the value for the input sine wave at the first pulse and also quantized signal at the first pulse. So you can just see clearly here for the first pulse, both the value for the input sine wave and also the quantized signal here is equal to 0. Okay, it's approximately equal to 0. Okay, so this is the value that you have to take. Okay, for the first cursor, just take 0.045. For the second cursor is the value that we want to take for the quantized signal. So we have to take a discrete value, which means just round it up to 0. Okay, so this one you can take 0.045, and for the second one, for the quantized signal, is just equal to 0. Okay, now we go to the second pulse. Okay, take the first cursor first. Okay, we go to the second pulse here. So this is the second pulse. This one is the second pulse. Okay, you just move the first cursor to this one here, where the second pulse occur. Okay, the second pulse occur here, and this is where you get the value for the input sine wave. Okay, so this is the value for the second pulse input sine wave, 2.556. Okay, so you have to take this value and write down inside your table 9.2. Okay, so you can get the table 9.2 inside your lab manual. And then for the second pulse, the value for the quantized signal, just move this second cursor here up to the second pulse of the quantized signal. So you will get 3.005. So as told you before this, you have to just write down the discrete value here, which is just equal to 3. Repeat the same process for the other pulse. Okay, so for the third pulse, this is the third pulse. You have to move the first cursor first to get the sine wave value. So this is the third pulse. So the value that you get is approximately 2.724. For the quantized signal, it is still the same as before, which is 3.005, and you just write down the discrete value, which is equal to 3. For the fourth pulse, so you have to move the cursor, okay, the first cursor here, move to where the fourth pulse occur. So this is the fourth pulse here. So this is the value that we get for the input sine wave, which is equal to 0.463. Okay, and then for the quantized signal, we just have to move the second cursor here to where the fourth pulse is occurred. So you can see here, at the fourth pulse, the quantized signal is approximately equal to 0. Okay, now we go to the next pulse, which is the fifth one. Okay, so this is where the fifth pulse occur. You move the first cursor first to the fifth pulse here. So you get the value for the fifth pulse is minus 2.216, and the quantized signal here is equal to minus 2.056. You just round it up to minus 2. For the sixth pulse, just have to move the cursor here to where the sixth pulse occur, approximately here, minus 2.843. This is the value for the input sine wave at the sixth pulse, minus 2.843. And for the quantized signal, it is approximately equal to minus 3.053. So you just have to write minus 3. Okay, for the seventh pulse, this is where the seventh pulse occur. Move the first cursor to the seventh pulse here, and then for the quantized signal, move the second cursor here. So you will get the value approximately minus 0.792 for the sine wave and minus 1.017 for quantized signal. We just round up, become minus 1. Okay, for the 8th pulse, move the cursor here. This is where the 8th pulse occur. So you will get around 1.97. And what about the quantized signal? Just move it. So you will get around 2.011, and just write down 2. For the 9th pulse, this is where the 9th pulse occur. Just move the first cursor here to where the 9th pulse is occur. So you will get around 2.97. And for the quantized signal is 3.005. So just write down 3. And the last one, the 10th pulse, just move the cursor to where it occurs. Just write 1.217 for 10th pulse, input sine wave. And for the quantized signal, 1.017. So you just write down is equal to 1. Okay, so you have to write all of this value inside table 9.2, and after that you have to insert the code number, PCM code, and calculate the quantization error.